Good afternoon, everybody. Welcome to class today. Looks like several of you have found the live stream, and that's great. Really appreciate that. Really appreciate you guys tuning in to watch the class live streams. You've got a lot of things that you can do with your time, and choosing to tune in and watch these live streams is well appreciated. And also, for those of you who are watching this recorded later on, thank you for watching. Really appreciate that. You know, these live streams go a long way to help filling in some gaps that you might be encountering as you're working through the material. And, you know, being here with me live gives you the opportunity to ask questions, engage in the material, and, you know, do some things that you might otherwise not get the opportunity to do in an online class. You know, I do like doing my live streams on YouTube. You know, it is a little bit different from probably a lot of the other online classes that you might encounter that have a live class component. You know, a lot of them probably use Zoom or Microsoft Teams, but, you know, with YouTube, I figure, you know, most people probably have a YouTube account already. You can get on and watch without any additional software like you'd need to have with Zoom or with Teams. And, you know, while all of the features aren't quite there, we can still have the opportunity to engage and chat with one another via the, you know, you ask your questions via the chat box there. If you have anything, and we'll be doing this about once a week. There'll be some weeks when we'll miss, but it'll be okay. We'll just do what we need to do. I'll usually post some kind of supplement in lieu of a live stream if we have to miss a week. So we are just kind of doing Module 1 this week, and it's an introductory module, and it's introducing Python. This is Introduction to Programming and Logic. And in introducing programming and logic, what we want to do is we want to actually have you programming, which seems like a novel concept in a programming class. But essentially what we do is we start at the very beginning, because while, you know, there are a lot of my programming and web students in here, there are also a lot of students that are in the networking department, because this is going to be crucial for you all to learn as well, because when you think about how the networking of the future gets done, when you look at server deployment and various other network deployment things that are happening today, a lot of that stuff happens via automated scripts that are by and large written in a programming language like Python, a lot of times in Python. So Python is one of the most widely used programming languages in the world. Last I checked, it was in the top 3, which makes it a useful skill to have to learn Python. But it's also a very friendly language to learn. You know, it's not really incredibly difficult to learn. The syntax is relatively easy, very close to what we would call natural language, being like English, right? And so when we're trying to learn the concepts around programming and logic, and we're trying to learn things like data structures, and we're trying to learn logic concepts and various other elements of that nature, it's nice to have something that's easy and friendly and widely used to have as the base for the programming. So we're going to start talking about some Module 1 material today. And you'll have your Module 1 labs, and we'll try to show you how to use the online IDE environment or integrated development environment before we end the live stream today. But let's start out by kind of going back and just kind of defining a few terms, some things that might be important to us as we're going to be talking about them throughout the semester. One of which is just, what is a program? I think this is an important thing to define as we get started. And when we're talking about a program, we're talking about a sequence of instructions that specifies how to perform a computation. Right? So a sequence of instructions. So we have multiple instructions. And one of the things that we can kind of utilize to kind of think about what a program is like an instruction manual. You know, as we're approaching these concepts, we can kind of think of the idea of a program as an instruction manual. Let's say you went to IKEA, you got a new table, you get it home and you're getting ready to put it together, right? So you get all the pieces, you lay them out, you know, you get everything in its own place. And then you pull out the instruction manual to see just how everything fits together. And it's going to give you step-by-step instructions of all the various things that you need to do in order to be successful in putting this table together. It's not going to skip any steps. It's just going to go from step 1 all the way through to step 7 or 8 or however many there are, just in order. And by following those instructions, you end up with a table. And we can kind of think about you in this analogy here as being like the computer or the interpreter of the programming language. So you're given this set of instructions with the goal of a problem to be solved or some kind of computation to be completed. And by following these instructions step by step, you get from that initial state to that goal state where you have whatever you wanted to have done. And when we think about the word computation, like computation is a big word. Like that's one of the word, you know, that's one of the things that you'll kind of notice as we kind of progress is that, you know, we'll introduce and talk about these vocabulary terms. And these vocabulary terms are oftentimes like big words for small concepts. Big words for things that we can understand fairly well. You know, when we think about a computation, what we're really thinking about is just solving a problem. Right? And like you can think about it in terms of math class, right? Like what are you doing when you're doing math class homework? You're doing computations or you're just solving problems. And we can think about a computation in this sort of way as just solving a problem. It can be something mathematical. And oftentimes it is, you know, it's built on equations and numbers and, you know, our advanced knowledge of math that we've learned over the years. Although one could argue that you don't really have to know that much math to be an efficient programmer. Maybe one of the things that I'll show you down the line that's always fun to show is about how in programming all math can be addition, which is kind of interesting. Let that kind of stew in your brain for a little bit and think about how all math can be addition. I do have a program that I have written that is a proof of concept where I have divided by adding. The only operator that I use is the addition operator to divide numbers, and it's pretty interesting. So that might be something that we circle back to a little later on in the course when we have some more understanding of what we're doing with programming. So it could be something mathematic, or it could be what we term symbolic computation. Things that are involving like words and pictures and videos. You know, one of the things that we'll be doing when we get to some of the later modules, like Module 6, is string manipulation. So we're taking and searching and replacing text in a document. That's something that we'll be doing. Like we'll actually be doing that. Processing an image, playing a video, we don't get that far in this course, but we start ourselves on a path where we could do stuff like that with our symbolic computations. So that kind of breaks down the idea of computation in terms of a sequence of instructions that provide or that specifies how to perform a computation. But what that doesn't determine for us is just what exactly an instruction is. So for our purposes, an instruction is simply a line of code. One line in your program that does something, anything. That's an instruction. And while the details of how we write these instructions are different in every language, right? Like if you go to Python or you go to Java or you go to C or C++ or Ruby or PHP, whatever programming language you go to, it's going to be different in how you write it. We call that syntax. And all these little syntax details in every different programming language, they're a little different. But what's bigger, the bigger concept that's going to be the central focus of this course is the logic behind how we program. And if you can understand that logic, the same logic and the same data structures are applied to every single programming language. So for example, like I might not know how to write a conditional in C++, but if I know that a conditional needs to be used in a certain spot, well, syntax comes from a book. I can go look that up. How to write the conditional. So the big thing and the big goal of this course is to get behind that logic and get you thinking programmatically. You know, that's for the first 3 modules. We have some interesting discussion topics that are in there that try to get you to think programmatically. They're not intended to be difficult. They're not intended to be trick questions, but they're trying to get you to think on a different plane and utilize programmatic thinking. So they're a little bit different and they're a little bit wild. But we also see these few basic instructions that appear in every language, things like inputs, right? You need to be able to get data from a user. So you need to be able to get data from a keyboard, pull in data from a file, pull data from the network like a database or something, just pull in data from somewhere to be processed in your program. It goes back to that whole idea of the data cycle, right? Many of you might know about the data cycle. We have this idea in terms of the data cycle that we have data, and this is actually the difference between data and information, by the way, in case you don't know. Data being a raw, untapped resource. We have the data as the input. We run it through a process and it's that process that makes our data valuable because it's taken our data from something that's raw, that might just be a raw bunch of numbers or a series of strings of words, something that really doesn't mean a whole lot to us on its own. We run it through a process, and that process gives it value and has it become information. And it's this information that's really valuable. And this is the data cycle. If you hear part of the data cycle, if you hear somebody talking about the data cycle, that's what they're referring to. Taking data and running it through a process and turning it into information. So we have to have an input as a source to get data from so that we can process it via our program and turn it into information. That information thereby is our output. We're displaying that information on our screen, or we're saving it to a file, or we're sending it to somebody, or we're sending it back to a database. All programming languages can do math. I contend that one of the reasons that we invented computers and programming to begin with was just because math is hard and math sucks. Right? So if math is hard and we want to make life easier for ourselves, well, it'd be a whole lot easier to write something that we could use over and over and over again that would help us solve equations and do the math for us, like a program. Conditional execution, being able to check for certain conditions and run the appropriate code. You might hear these termed as if statements. If you've ever kind of been tangentially around programming or working in any kind of programming before, you might have heard of an if statement or a conditional. And repetition, being able to perform some action repeatedly, usually with some variation. And we discuss in this class two ways that we can do repetition in programming. We talk about recursion and we talk about a loop. And really what we see here is the basis for the three standard data structures that we encounter in a program. We have a linear data structure. We have a conditional data structure. And we have a recursive or looping data structure. And this has to do with the way that our interpreter reads our instructions. So the interpreter reads the instructions. In most standard programs, we see a linear data structure. The first three modules, we focus solely on a linear data structure, meaning that we start at the top and we go straight down to the bottom, executing the code as we go through it. The second thing is a conditional data structure. The conditionals, as we've mentioned, give our program the opportunity to make decisions. If something is true, then we run this code. If it's not true, then we run some other code. And so what this data structure allows us to do is it gives us branches where we get this sort of tree-like structure, where we have different paths that our interpreter can follow based on conditions that are either true or false. And finally, we have our recursive or looping data structure, and this is a data structure that can take a particular process and run it over and over and over again until you no longer need it. So these are processes that's true for every single programming language in existence. But we're not using every single programming language in existence. We're using a particular programming language. We're using Python. So what is Python? Well, it was created by a Dutch programmer by the name of Guido van Rossum, 1991. So it's older than you might think. Like, we've heard a lot about Python sort of in the IT sphere as it's sort of gained traction in use in industry and various other applications. We see it used in automation. We see it used in data science. We see it used in simple software programming. Now in web development with like Python-based stacks, like if you use Django or there are several other server softwares that allow you to use Python on your server so it can be implemented in web development. So it's been around a while. It's been around longer than we think. I mean, we're in the 30th anniversary year of Python right now, right? So when we think about Python, even though we've heard a lot more about it in the last few years, 5 to 10 years maybe, it's been around a while, and it's a high-level programming language. When we think about high-level programming languages versus low-level programming languages, the higher the level of the programming language, the more close that it is to what we would call natural language. Natural language being English, something that, you speak. Something that we use to communicate with other human beings. So we consider Python a high-level programming language because it's more similar to a language that we speak than it is to something that is machine code. Binary zeros and ones. When you get into some older standard programming, things like C, which is still widely used today, your standard C is more of a low-level programming language, although it's still considered to be a high-level programming language. Really, when we get into low-level languages, we're talking about things like assembly, things of that nature. But it is sort of a spectrum as far as all that goes. It is open source and community driven, so you can go to GitHub right now and see the source code for Python. You can go to the python.org website, and I believe they have their GitHub linked right off of that. So we have source code that you can go see, and it is community driven. It is, it's on GitHub, and you can make pull requests and modify the code base, although most likely you're not going to get your code added to the code base. But it's something that you could do hypothetically. And one of the things that we like to say about Python is that it is a batteries included programming language, which means that it is the standard distribution, the base distribution of Python, has many different modules or libraries included with it. Things like the math module that we'll look at in a few weeks. They're not all loaded into your program by default, right? And that's in order to keep things sleek and streamlined. That way, you're not having this really bulky, memory-intensive program because you have all these modules loaded that you're not using. You still have to import them, but you don't have to download anything special. You don't have to do anything special to use a lot of these modules or libraries. And it's dynamically typed, which means that when I create a variable, when I create a function, when I create an object, I don't have to write what data type of element that it is. So if you're familiar with something like Java, which is strictly typed, right? You know that you have to, if you're making an integer variable, you have to declare it as an integer variable. Python is just smart enough to say this variable has an integer set to it, so it's an integer variable. So in that sort of way, it's a lot more friendly. We can get away with more stuff by using Python versus some other more complex programming languages. Now we have this Y here of YPython, and it's one of the most widely used programming languages in the world since 1991. We've already said all that, so we'll just kind of flow through that. And the whole idea of the course is that we can focus on programming logic without having to struggle with the syntax, because the syntax is relatively easy. And it's called Python because of the television series Monty Python's Flying Circus. Guido van Rossum was a big fan. So let's talk about running Python for a minute and how we run Python. So for simplicity's sake, we have our online IDE. IDE stands for Integrated Development Environment, and that's REPL.IT. And that's in the Begin Here module. You should have created yourself an account for this site. You're going to need it. If you like, you can use the standard Python IDE, which is called idle. I have the instructions in the Begin Here module as well for installing that. But it's a whole lot easier on me, and it's a whole lot easier on you. It's easier for the both of us if you just use the online IDE. And we're using Python 3 in this course. Python 2 is on the road to being sundowned. It's still in use a little bit out there, but Python 3 is the current version of Python, so that's what we're going to be using. So while we're talking about it, let's head over to REPL.it, just so I can show you this environment and what we can do with it. Let me pull up my screen here. And we'll go full screen. So after you log in, you'll see a screen that looks similar to this. You know, if you're just creating your account for the first time, you won't have any of the recents here because you don't have anything. But this is our online IDE. And you can actually program in a whole lot of different languages on this. So this is something, you know, once you have this account, you can hold on to this account. You can use it for different things. Python, Java, we use it in both of those classes. You can also do some HTML, CSS, and JavaScript in here. There's also some other programming. There's a ton of programming languages in here. If you want to play with them, there's a React stack that's built into here. There's all sorts of different programming languages. Like I have C# here, where I was noodling around with it for a little bit. All sorts of different languages. Like we can click the languages tab here and just kind of run through and see everything. Python, Node, C, Java, C++, Ruby, Scheme, Go, Rust. Just all kinds of different programming languages, and programming languages with additional libraries built into them. Like, for example, here we have Python with Pygame and Python with Pixel, which are game engines for Python. So it's the Python programming language with another game engine put on top of it. And you can just come in here and do your programming and have a great time. Let me head back to my home page here. So what you're going to want for the first time is you're going to want to come up here to the upper left-hand corner, and you're going to want to click this New REPL button. And that's going to pop up a modal on the screen to give you the opportunity to create your new program. So I've got the stuff that I use the most often. They're in my favorites here: Python, HTML, CSS, and JavaScript, and Java. And so if you're starting out for the first time, you probably won't have Python there, or you might not have anything there. So we want to type in Python here. And you see a lot of stuff here. You see Python, Python 2.7, Python with Turtle, which is kind of fun if you want to kind of practice that. Want to kind of play with that a little bit and look that up on your own kind of spare time. The Pygame and tkinter, which is a GUI add-on for Python, but also with a bunch of templates down here. The one that we're using, the one that is Python 3, is the first one here, Python. And then it's going to give you an option to name it. Go ahead and name it. We'll call this CIS 115 Sp21 OL. Since I'm doing two different sections of this class, one's seated and one's online, so I gotta have these crazy long names. Demo program. But when you're doing yours, you can just name it whatever the assignment's called, or do whatever you want. And then I can create my REPL. And this gives us our screen where we can start our coding. We have the files that are in our program here to the left-hand side, our actual code window in the center here, and our output console on the right. As we get started, our files menu isn't going to be too important, but once we get into modules oh, what module is it? I think 8, where we're working with files. This will become incredibly important. And we can start typing our code here. And one of the great things about this too is when you want to turn in assignments, all you have to do, since you've named it and you've done everything you're supposed to do, this URL here is unique for every REPL. As you can see here, it's got my username, it's got the title of my program. When you're ready to turn something in, all you have to do is highlight the URL that you have here, copy it, and you can put that in the right submission box on Blackboard, and I'll get it. I can just click the link and go straight to it. So we've got this environment here that we can use to program, and we're going to play with it just a little bit. I don't want to go too much longer here because I don't like my live streams to go crazy long. But I do want to kind of examine another concept before I let you go today. So one of the things that I expect to see at the top of every program is a shebang. A shebang. So every Python program should start off with a line called a shebang. And the term shebang is a portmanteau, or a combination of words, hash and bang. Hash being the hashtag or number symbol, and bang being another term for the exclamation point. So our shebang line in any script determines the script's ability to be executed like a standalone executable without typing Python beforehand in the terminal or when double-clicking a file in the file manager. So when I go to run this file, if I'm running it via, if I have this file downloaded on my computer and I want to run it, I have Python installed, I can just type in the name and my command line and hit enter and it'll run it, or I can double-click it and it'll run it because we have this shebang. The shebang gives that instruction to the interpreter that this is a file that we can run and use. And it makes our life a whole lot easier for the purposes of actually using our programs down the line. So for Python 3, our shebang should look like what we have demonstrated here. That's hashtag, bang symbol, or exclamation point, /USR/BIN/ENV, Python 3. And I'll be looking for this in everything you turn in. Make sure to include this line at the very tip top of your program. I'll be looking for it, and I'll be counting off if it's not there. We want to see this in everything you turn in. And so with this, we'll do a little bit of a demonstration here before we go, and we will write a hello world. Because I think a hello world is a good way to finish off our first live stream here. Because by the time we talk about what a hello world is and we actually go and write it, we'll be pushing 45 minutes, and I think it'll be about time to go. I can show you some other stuff while we're doing that, but I think it's going to, be fairly simple for us to just kind of end our live stream by doing the hello world today, and then letting you get the rest of the material from the module and from your practice. So in normal coding classes or normal programming classes, the hello world is usually going to be your first assignment. It's one of these things where essentially you're saying, hello world, I'm using this programming language. The most basic program you can write, the easiest thing you can do. Easy peasy. But in this class, it's not. Because it's too easy in Python. So let's just write our Python hello world here, and we'll just see how it is. Let me switch back over to our REPL window here, and I'll make it full screen again. And I'll even zoom in here so we can see my code a little better. Now, the first thing that I'm going to do here, because it's something that I'm expecting you all to do in every single program that you write from here on out, is I'm going to write my shebang. So that's hash bang /usr/bin /env Python 3. And that gives us our shebang. So we're good to go and progress on to writing our program. Now, I liken this course to like the idea of a snowball rolling down a hill. We start out with really simple, really basic, really easy concepts. And as we progress, everything kind of builds on itself until we get bigger and bigger and bigger and bigger at the end. Now, one of the things to keep in mind is that you learn everything you need to know as you progress. What makes the lab assignments hard, or difficult, I should say, challenging is probably the best word. What makes the lab assignments challenging is trying to figure out the proper order in which to put all of the little pieces that we're learning. And that's where the logic comes in. So I'm going to go ahead and encourage you now, even though things are really easy now, it's going to be a good habit to get into as we progress. Before you start typing in your IDE, take out a pen, take out a pencil, take out some paper, and map out the steps of what you need to do. Create that instruction list like you're going to build that IKEA table that we talked about earlier. And that way you have this guide to follow as you're writing your program and including your different instructions in your program. All you're doing at that point is you're just translating it from natural language into high-level programming language. And life becomes a lot easier. You know, you can think about it like when you're in high school and they're like, oh, here, you need to map out, you need to outline your term paper, your essay, before you write it. You know, we can kind of think of it in a similar way, except it's a whole lot more useful. So in writing our hello world, essentially all we want to do here is we want to echo the words hello world into our console. And so if we want to echo text out into our console, in Python we use a print statement. So we're going to use the word print, include our parentheses, include some quotes in there to denote a string. When we're working with strings, all of our strings have quotes around them. If it has a quote around them, it's a string. Even if it's some kind of number, if it has a quote around it, it's a string. And something to keep in mind is that you can't do math with strings. So if you're working with strings, and you need to do some math with a number that you have converted into a string, you need to do what we call typecasting it. And we'll look a little bit more at how we typecast next week in our live stream. So I'm going to print out hello world to our console. And this is the hello world. This is exactly why we don't do the hello world as the first week's assignment in this class, because it's way too easy. You'd just turn in this and you'd be done. Question. What if you mess up the user bin environment Python 3? Will it affect the program? If you have this here, if you still have the shebang there, it won't affect the program. It just won't do the run properly. Right? So like when I talk about like, oh, you can double click to execute it, that won't work. As long as you have that hashtag and exclamation point there. Really the hashtag, because it's also a comment symbol. So it'll just comment out that line, and the interpreter will ignore it. But if you mess up the rest of it here, not a huge deal. It just won't do what it's supposed to do in terms of doing that double click for execution sort of thing. So it's not quite as flexible as we might want it to be. That's a good question. Thank you for that question. But, it's also one of those things where like it's going to be the same thing every single time. Just have it somewhere where you can like copy and paste it and put it in. Right? Not a big deal. And one of the things to note as well is if we get something way wrong, like if we forget and leave out that's why we use an IDE. Our IDE tells us, hey, there's something wrong here. I don't know what it is, but there's something wrong here. And if we hover over that, we can see we have an invalid syntax error. And so we know that it's something that we have to look into. So we need to put our shebang back there. So this is really quite simple. From here, all we do is press run. We can see that it prints out hello world to our console. And we have a Python hello world. And we can put whatever we want inside of this print statement. We can put numbers, like 16. It'll give us 16. We can put equations, like 16 plus 19. It'll evaluate that equation and give us an answer. 35. Any of our basic operators, like subtract, or multiply, or divide, they all work. 16 divided by 19, a nice little floating point number. There it is. 0.84211052, so on and so forth. And so that's kind of what you're doing in your first lab assignment for the module 1, is that you're given some equations to write. You're just writing the equations in different print statements. Ideally, we're just trying to get you used to the environment here and used to playing in the programming language and working in the environment. That's why you have the experimentation lab as one of your module 1 labs and the equation lab as your module 1 labs, because we're just kind of getting our toe wet. We're just dipping our toe in the water of what we're doing with the programming language. And next time when we start talking about variables and working with some bigger concepts, we'll start to hone in on some more programmatic things. So really, that's all that I have for you for this week. I think that's probably good enough. Let me just check my slide deck here, make sure there's nothing else super important that I need to talk about. You know what? I think there is something else that I need to talk about here, and I think I need to just talk about debugging for a second, because I think that's important as we get started on our journey this semester, because it is going to be a journey. Line 1 here. Programmers make mistakes. I can't tell you how many times when I've been writing something and I've just been frustrated by what I'm working on, and I'm struggling to figure out a solution. And it's a part of life as you're trying to learn how to program, especially if you've never done anything with programming before, it's going to be a little more difficult. But as you progress and as you grow and as you learn, because that's what we're doing here, we're learning. As you learn, you get better. And when you get better, at some point that light bulb goes off and you're like, oh man, I understand this now. I can do this now. And if I move this here and I do this here and I do that there, it's gonna give me my answer. It's gonna solve my problem. And that's huge. I mean, when you make a mistake in a program, we call it a bug. And that's actually comes from the days of pre-digital computers, back when computers were mechanical. A bug actually flew into the computer. It was a moth. And when you're having to use mechanical parts and punch cards and things of that nature, a moth getting in the works can cause an issue. And one of the big things to remember here, though, that's kind of whimsical and that's kind of funny. But one of the big things to remember here is that when you're debugging and you're working on your programs and it's just not going the way that you want it to go, it can really bring out some strong emotions. There's a slide I show in the Java class that's similar to this, where I was working in Unity and I was building a game. And it wasn't so much my code as it was just Unity not cooperating with me. But you can see in the different versions of the file that I've rendered out, just my descent into madness, as each time doesn't really get much better. It happens. It happens to everybody. It happens to people who've been programming for 20 years. Who've been programming all their life. So especially when you're just starting out, if you hit a wall and you feel this anger or despondency or you feel embarrassed, it's not personal. Right? One of the big lessons that we learn out of this isn't just programming, but it's being able to push ourselves to try to solve a problem even when things seem like they're not going our way. Taking these problem-solving skills and moving them in a particular direction. So if there's one thing that I hope that you learn, in addition to programming and logic this semester, it's persistence. Nobody knows everything. Nobody knows everything right away. Anything that's brand new is going to present some sort of challenge. Keep going. You can kind of think of it in relation in terms of the idea of the runner's high. That might be something that you've heard of. Maybe you have, maybe you haven't. It's this idea where, you're a runner, maybe you're a marathon runner, and you run for so long, right? And you're starting to get tired, and you're starting to your body's just starting to lag out, and you're feeling awful. But all of a sudden, you just hit this particular stride, where the adrenaline starts pumping, the endorphins start rushing, and you feel like you could just run forever at that point. You get this runner's high. And really, in programming, we see something that's very, it can be very similar. You can just bang your head against the wall just over and over and over again, trying to figure something out. But that moment when you do figure it out, next level. Level up, +1. So it's something to remember as we approach this semester. Might be tough. You be tougher. So that's all that I have for you for this live stream. We've hit about 50 minutes, which is, past the time that I like to go. I don't like these to be too long, just because I feel like people will be more inclined to watch them if they're a little shorter. But sometimes, you just have to get it out there. I'll hang out in the chat for just a couple more minutes, just in case anybody has any more questions. So if you want to ask some questions in the chat after, right now, essentially, feel free to do so, and I'll answer them in the chat. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.
rather it's about tending to the broken parts inside of ourselves. We create things as a reflection of this struggle to study our perception of self. That wave isn't necessarily a thing you achieve. Rather, it is a state of mind which you constantly strive toward. This all comes from an understanding